integration framework. Originally, this talk was supposed to be given by Giuseppe and Peter, but unfortunately, due to travel restrictions, Giuseppe was not able to make it, so you all are stuck with me instead. So let's get started. Today, we live in a world of many networks, as many are probably familiar. As an example, here's the internet in some kind of artistic rendering. It's hugely complicated. If you're a business, oftentimes you have to work on many networks. And this is what, say, a network or a collection of networks for a business might look like today. Very centralized, but still connected. So obviously, we're at a blockchain conference. So the question you have to ask is, what about blockchain? Well, in a blockchain, it's going to be substantially more complicated. Decentralization has some cost, and obviously, what we need is going to be a lot more difficult. And many of the blockchains that we're going to replace these traditional networks with are going to have requirements that are substantially more difficult to guarantee than in the centralized world. So as an example, right, some of our blockchains and membership services might need decentralized identity support. If we don't have central servers anymore, this is something we might need. Other blockchains might need great scalability. I'm sure many of you are familiar with the difficulty of scaling blockchains. So we often have to give up a lot of security or privacy properties to get good scalability. Other blockchains or parts of blockchains might need extra cryptography for privacy. Some blockchains might need very fast transaction speeds or good performance. There are a lot of blockchains that need legacy compatibility. And even some blockchains need auditor support, which again, might be very simple or easy for a centralized solution, but more difficult for a blockchain. So what does this lead to? Well, essentially, we sort of feel that there will be no one blockchain to rule them all. We will have to use many different blockchains for many different applications, and there's no platform that's going to be right for everybody. And what does this mean for us? Well, a really important part of this wider network ecosystem is going to be communication between blockchains. And you can see here that I've outlined sort of these different communication protocols between these various blockchains. So this brings us what we're here for today. So with the blockchain integration framework, we intend to define a communication model that enables permissioned blockchain ecosystems to exchange really anything, any on-chain data, any assets, independent of the platform, and without a middleman wherever possible. So we thought about this a little bit, and some of the basic core requirements we wanted are as follows. So we want a system that's maximally pluggable and maximally general. This will sort of minimize future work. We want to eliminate middlemen whenever possible. We don't want to have to go through and implicitly trust intermediate blockchains unless we absolutely have to. We don't want to use a token. When we're building software for enterprises, we really don't want to mandate that our clients or customers use tokens. And finally, we don't want to mandate a toll booth. We don't want to require operators to have to make money by taking a cut for intermediate transactions, as in many cases, the incentives are aligned for people to complete interoperable transactions. So what does the interoperability space look like today? Here's a moderate assortment of current solutions in the space. But unfortunately, none of these existing solutions sort of satisfy the core principles we mentioned earlier that are essential for the enterprise use cases. So fundamentally, we came to the conclusion that we needed a new way of doing interoperability. And this is where collaboration comes in. So we at Fujitsu and Accenture sort of independently came to these conclusions that a new interoperability solution was needed, and we sort of both built our own. So once we all realized that we wanted to open source our solutions, we decided it would be more efficient to work together than to continue on with our separate solutions. So our current status is we have 2 independently working code bases for interoperability, one from each company. They're currently open sourced in Hyperledger Labs, and you can see them and play with them for yourself. And we're in the process of merging the code together to build a best of both worlds solutions that we think will give us all of the use cases of both code bases. And you can see, some sort of work in progress diagramming of what our interoperability solution might look like. So the question you might have is, what does a general interoperability platform need to look like, and how can we go about building it? Is it possible? And with that, I will turn the presentation over to Peter.
Hey everyone, I'm Peter Shimojivari. I will talk about the rest of it. So first and foremost, we need wide support. If we want it to be successful, people need to use it, and people have a lot of different requirements, so we need to try to capture a lot of those together. It also has to be pluggable. I'll return to that later in a lot more depth. Where applicable, we want to prevent double spending, of course, but that's kind of a can of worms, and it's not always strictly possible. So we just want to make sure that when it's possible, then it has to be done. And then the features of the ledgers. If you have a ledger that has something unique that most other ledgers don't do, we don't want you to lose that. It has to work with the blockchain integration framework. And last but not least, it has to be low impact. We don't want to force you to have to fork the code base of some ledger that's out there just so that you can work with the integration framework. There's a complete list of these in the white paper. So I'll keep returning to that. I highly recommend that everyone, if you have the time, you look at the white paper. We will provide links for that. So one of our core components is the Interoperability Validator. It's basically a server-side application that sits at the deployment of your ledger and the software stack that you chose to operate it with. And it provides you with high availability through an overlay network. Currently, it has leader elections built in, but we're planning on removing that. The network services that a validator will give you on a high level is basically to handle your export requests. An export request is when you have a piece of data on one ledger and you want to move it to another ledger. Also, the big feature there is to be able to verify the state of one ledger on the other one. And we achieve this by managing the trusted foreign validators, essentially just putting or dispersing public keys of the validators on the ledgers within smart contracts. Some technical information that you should be aware of. Our code is in JavaScript, but through the plugin architecture, we plan on supporting different languages as well. There's some great patterns out there. One that we've seen is how the Go plugin project implements it. They can, you pass in a command line argument that starts a binary. The binary ends up listening for gRCP requests, and your actual core software that interacts with the plugin, it communicates with that other binary through that gRPC. And then in this structure, it doesn't really matter what you use to implement your plugin. It could have been any language that had support for that API. This is one of our example use cases. There's many of them in the white paper. You should go and read it. I'm not going to go into too much detail here. I'll just highlight the beginning of the sequence, which is proposing the transaction. That's where you get to specify the constraints of the transaction, as in how do you want it to be handled? Should there be an escrow? If you are transacting with a permissionless ledger, then maybe you want to put a limit in there for the number of blocks that you want confirmed before the transaction can be finalized on your end. And also it demonstrates greatly that BIF, the Blockchain Integration Framework, is a common API layer in front of other ledgers, in this example, Fabric and Basic. So the architecture-wise, what you need to implement yourself is you have to either connect to somebody else's ledger or run your own. That's entirely up to you. You need that ledger's SDK, and then on top of that is the abstraction layer. That's us, the Blockchain Integration Framework, which you can use for the validation services and the data export.